So in this section, we're going to be talking about automating Asterisk on Kubernetes using Ansible Playbook Bundles. So what's the gist? So we're going to create a basic Ansible Playbook Bundle. I'm going to apologize now. I guarantee at least once I'm going to say Asterisk when I mean Ansible, and I'm going to say Ansible when I mean Asterisk. It's going to happen. I'm hoping Doug will correct me and set us straight, but just be aware, I'm definitely going to do that probably once. So we're going to create a basic Ansible Playbook Bundle and some infrastructure. So I'm going to do an overview of what APBs are, or what Ansible Playbook Bundles are, how to provision Asterisk from a custom APB, and create an Asterisk and get it running in OpenShift. So Ansible Playbook Bundles, primary areas of focus during this. So what are they? Why do we need them? What do they offer us? What's the general workflow of building an APB? I'm going to do a demo of APB building and a deployment and getting it into OpenShift. And then we'll have some discussion about bindings and secrets and stuff like that if we have time, and any other questions that people have. So this comes from the folks who work on and are developing Ansible Playbook Bundles. So what are their inspiration and goals for this project? The solution for defining and delivering simple to complex multi-container applications, making it easy to orchestrate the services using a very lightweight application definition, and leverage the container image as a transport mechanism for delivering the application. So the idea is to be able to bundle a Docker file with the application and effectively build something similar to like what an RPM or a deb file would be, where you have this kind of package that you can run and get things up and running, and everything being bundled together. The idea is to make sure that it's simple, but is very easy to use and can be extended and can be leveraged in lots of different situations. So not biased or as limited in its bias as possible. Needs to work with new and pre-existing application container images. The idea is to build an extensive ecosystem to make this available within the Kubernetes service catalog, and growing interest and participation on this application system. So the way this works, and I'm going to go through this slide because it's pretty wordy, but really the bottom part is the big thing. And so the idea is that inside of Kubernetes, there's an open service broker API. And so this is an API that Kubernetes exposes that allows you to build basically controllers, or what we call brokers, to interact with this API. And some of the functionality that this API provides are these methods. And so we have catalog, which is going to return a list of service offerings. So the idea is that just like if you were to go into AWS and you have an application catalog or a list of applications. So I want to spin up a MySQL or a MongoDB or an Asterisk, that there's a little pretty icon in the service catalog, and I can go click on it, enter some data, and it's going to spin it up and make it available to me. So that's the whole idea behind this service broker API, is to provide that type of functionality that allows you to spin up these applications in a simple way. And so the methods that the service broker API, like I mentioned, there's catalog, which is going to return the objects that exist that it's able to provision. Provisioning, which is actually just creating the service. Deprovisioning, which is deleting the service. Binding, which is a way of obtaining credentials or the coordinates, like where the application lives inside of within OpenShift or Kubernetes itself. And unbind, which is deleting those credentials. And then update, which allows you to basically run an update script to move to new versions and provide some basic lifecycle management functionality. So Ansible Playbook Bundle definition. This is kind of what it looks like to a certain degree. So really what it is it's a container image that contains an Ansible runtime. And Ansible, again, is functionality that allows you to provide automation in order to script out how you want things to happen. And so Ansible has kind of a basic directory structure, and part of this directory structure is going to provide different playbooks. And these playbooks are the actions that are actually going to happen when the methods are being called against the service catalog. So like I said, there's provisioning, deprovisioning, binding, unbinding, update, and stuff like that. So that's what's kind of you see here. So when I do a provision, it's going to call the provision.yaml playbook, which is then going to go in and execute against this deployment role that's going to basically do all the spin up and the configuration of the application for you. Again, deprovisioning is, how do I delete it? How do I get it, spun down? Things like that. And the big one is going to be apb.yaml, which is a metadata file of what this application is, what things I can ask the user when they spin it up. So if I need to know addresses or names or things like that, that definition exists in the metadata, which is also the naming of the images, how it's going to show up in the service catalog, what its icon is, things like that. So once we get into looking at this at the console, it should be significantly more clear. So this is probably maybe less useful of a slide for this presentation, but so a lot of people will be like, well, what about operators? And from my viewpoint, operators are great, and in fact, you might even use an APB to deploy the initial operator in order to get all the other functionality up and running. So we'll come back to that. We have a whole section on operators, and it's still early days of trying to figure out where all of these components fit together and who uses what, and maybe you pick kind of one because one's simpler and you don't really have a lot of changes because operators can be a little bit complex sometimes and they're fairly new, so maybe they don't make sense for everyone. So we shall see. So why APBs versus basically other packaging formats or other templating engines? And for me, the big one is just usability, the user experience. It's a really nice and simple way of getting things into a service catalog and making it exposed so that you can just go and use it. It's just point and click, next, 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 and get your application up and running. I'm a big fan of Ansible, so it's just one less thing for me to have to learn. So, instead of learning kind of the templating engine that Helm uses or building an entire operator or using like different templating engines that I'm not familiar with, that's why I like these.
Yeah, I would say that one of the big takeaways for why Ansible Playbook Bundles is because Ansible is great. And if you don't use Ansible in other parts of your platform, definitely give it a whirl. Because in my own experience with it, and I think Life had a fairly similar experience, which is I started with zero knowledge, I picked it up, I made playbooks in the first afternoon that I used it, and I never looked back because it really just wound up saving me a ton of time. So if you're already an Ansible user and you have Ansible as part of your platform, this technology definitely fits in with other stuff that you're doing.
It's effectively a way of bundling and packaging Ansible and making it available on Kubernetes. So it's really nice. I like it. So here's kind of the workflow a little bit. I wish I had some better diagrams here, but so like I mentioned, there's the Open Service Broker API, which has catalog, provision, deprovision, all those commands. We have the service consumer, which is me, layer 8. So I have the service catalog, which exposes an interface. And so I say, hey, I want to instantiate a new service or a new application. So in this case, it's going to be Asterisk. So then I go to the service catalog, and so the service catalog can have several different types of brokers. We're talking about the Ansible Service Broker today, but you could build your own other service broker. So that's why there's this stack down here. And so it can kind of flatten all the different applications and all the different functionality that can be exposed through the service catalog through all these different brokers. Ansible Service Broker happens to be one example of this. And so this is effectively our controller. It's built. You don't have to do anything with this. This is provided to you through the instantiation of spinning up the Ansible Service Broker from within OpenShift or Kubernetes. And so that service broker then understands that there's basically Ansible Playbook Bundles. So these are all the different applications that it's able to provide that gets returned via the catalog method. And so that's all stored within the container registry. So say I want to spin up my Asterisk, I go to the service catalog, I click on it, I say, hey, I'm going to spin up Asterisk. And Ansible Service Broker basically says, okay, great, I'm going to go ahead and do that. I'm going to execute the Ansible Playbook Bundle that it matches that application you've asked of me, and then it's going to run the Ansible within a container image that actually gets thrown away after it completes. So it spins up kind of a sandbox image, and that sandbox image runs all the Ansible that's bundled within the APB, and then it talks to Kubernetes and spins up the services and the other objects within Kubernetes, and then that sandbox gets thrown away. So it's just a temporary thing. So demo time. Dangerous demos. So let's see. Let's look at what one of these is. I'm going to try and make this a little bigger. Oh. Just give me a second here to get logged in. Any questions before I get into this? Oh, you know what? Before I get into the console, let's just look at what this looks like. Okay, so this, let's make sure. I'm just going to make sure that this is actually loading. Yep. All right. Cool.
So what are we looking at here, Life? What
this
is
is OpenShift. So I'm actually just going to log in right from the beginning. So we have some automation, and this is part of the hack session this afternoon is going to be actually spinning this up. So I built an entire, I built this last night basically out of our automation. And so we'll do some of that this afternoon. So here's our screen, here's our login. And so there's different projects. So you can build these projects for different purposes and kind of separate things out if you want. They're just namespaces effectively. And so this is the service catalog. This is what it looks like. So these are all the icons. These are all the applications that are being provided to us from the service catalog. You'll see some of them end in this APB, which kind of stands for Ansible Playbook Bundles, and those are the ones being provided to us from the Ansible Service Catalog, or also known as the Automation Broker. And then there's some other ones that are built in here just from the templating service broker, or template service broker. So you'll see some of these in here. And so I've taken the work that Doug did last year for VNF Asterisk, and I made it into an APB using Ansible and packaging it all up so that I can go into here. And so all the stuff that you had to do last year with all the manual commands and running spec files and running OC apply or kube control apply, I've automated using this APB. So click on the icon. In this case, it's not really going to ask me anything. It's just I'm just going to do next. I can create or add it to an existing project. So I have a project I created called AstroCon 2018. I'm going to click on that project, and then I'm going to create it. And then that's pretty much it. So what's going to happen here is it's going to create this provision service, and now Ansible is running in the background right now from within the that sandbox image, or sorry, that sandbox container, and it's spinning up all the other containers for me. So it's running all the commands for me, and now I have a VNF Asterisk basically up and running at this point. That's all I had to do. I just had to click on it, spin it up, it instantiates everything for me. I have all my pods, so I have the VNF UI, the controller, the etcd systems, and there's an asterisk in here as well. So if I go in here, so we were talking about services earlier. So the service is what's pointing at the pod effectively and has its own IP internally and what ports are exposed, and it's done using selectors. So Kubernetes uses a lot of labels, and labels is how you kind of attach things together within the infrastructure itself. So the service itself is basically pointing at pods using these labels so that it knows what to point at.
Right. So, we've talked about intent-based expression. So, we generally say, I want to have a workload running. But you may have something that is like a little bit more specific. Like you might want to say like a label that this machine has solid state disks. So you could say, I have a workload that's IO intensive, and it needs to run on a machine that has SSDs. So you could label a box as having SSDs, and then say this particular node or this particular workload needs to be assigned to a machine that's labeled as having an SSD, for example.
Yep. So let's see here. So inside of OpenShift is a concept called routes. And what routes are is basically the DNS that you're going to expose on the outside of your network in order to route to a service, which will then route to the pod inside. So using that route, I can basically change things inside and never have to really change the DNS name. And so when I build these services that exist, I can actually go in here. So to get access to the UI, right now I'm like, okay, it's running and it's got an internal IP address, but there's no way to access this UI right now. How do I get into it? There's no way to get there right now. So what I have to do is I can go in here and I can do create route, and I can name it. So what is going to happen is the DNS name. So okay, let me back up a little bit. The way this works is usually with wildcard DNS. So what will happen is when these routes get created, they'll get created in a specific subdomain, typically say .apps, my top level domain. So in my case, it's .apps, .astrakhan, .home, .61will.space. And that is basically my home network, .61will.space. And so I have that wildcard that says anything that is added, so doug.apps.astrakhan, blah, 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 that will point at a specific service, or I could have VNF UI in this case. So I'm going to create a route called VNF UI. I can also set the specific domain name here if I want, but I'm just going to let it do its thing. It's going to point at a service. So this are all the services that exist right now that I can point at. So I want to point at the VNF UI service. I can do all sorts of things like making it HTTPS, so that's all secure on the outside, but then it basically is clear text on the inside of the network. If that application isn't providing TLS certificates and all that sort of stuff, so at least I can make it secure up to the router, basically. And so I'm just going to hit create, and that's going to create the UI. There's the host name, and assuming that I have, and unfortunately I'm not at my home network, so this is a bit more of a pain than it needs to be, but I'm going to create a tunnel back to my home network, and if that works, I'm there. So now I've tunneled back over SSH to my UI. That's been exposed inside of my network, and unfortunately the controller is giving me some problems, so probably do in the afternoon. But what happens is this runs and connects to the controller. So really the next step at this point is because the UI wants to connect to the controller. And that controller, again, is not exposed, right? So I go back to my service. I go to my controller service. I create a route for it. I call it controller. And that would be it. So at this point, in theory, if I was at home, I would click on Discovered Instances, and it would list all my Asterisk instances that are running. So we can go to our overview. You can see our Asterisk here, this is our deployment, which is running a pod. And that pod is this VNF Asterisk. And so it's running 2 containers, Asterisk and the capture agent, which we saw in our diagram earlier. And then we can load the terminal. And basically, there we go. We have our Asterisk up and running. We're running 15.50 in this case. And that's it. So that's the whole thing. So everything is up and running. We have Asterisk, we have our UI, we have our controller, we have our etcds. All of that basically just happens. So now if I want to get rid of all of that, I can go to my provision service, actions, delete. I say delete it. Go back to my overview, and you should start seeing the pods spin down, and they'll get deleted, and it's going to do some cleanup. And all of that's done from the APB itself. So it's going and deleting the spec out of Kubernetes and telling it and saying, okay, let's delete all the components. And then eventually the provision service itself will get cleaned up by Kubernetes or the service catalog. So.
Right, and so in the theme of lifecycle management, we had when we brought up the pods, that was their life cycle began. The Ansible Playbook Bundle started to run. It brought up that sort of sandbox area where it ran the playbooks from. It did whatever configurations we need to have done. That last year was all manual, copy and paste this command, and instead we said, all right, we'll memorialize all that in Ansible Playbooks. So it did all of that stuff, and then we went and used it. And the reason that we had some manual configuration in the UI is because those would be things that you would do, like, say, for like a user access to this stuff. Like, so we needed a DNS name so we could get to a user interface. So that part didn't need to be automated. But then when we spun it down, then we also had stuff automated there.
Yeah, so when I spun it up, that's running the provision.yaml, and then when I did the delete, it's running deprovision.yaml. Those are the playbooks. So let's look at some of this, since we have plenty of time to do that, which is nice. So I've created a Git repository, github.com/lifemadsen/astricon2018, which is where all this is memorialized, and this is what we'll play with this afternoon. So within here, there's some scripts. These scripts, basically, I run the demo setup, and it's going to spin up the entire OpenShift instance for me, and the virtual machines and all that stuff. And then I have my APB. So I have a few APBs that I've started working on. The VNF Asterisk is the one that I was showing. So if we load apb.yaml, which is the metadata, it's actually pretty straightforward. This is it. This is the entire thing. The version, this is not the version of the APB itself, as I found out while going through this. This is what spec or version of APB itself it is that you're using. So effectively, it's always going to be 1.0 until that changes. There's actually a 1.1 or a 1.2 out now, but you have to be running a newer version of OpenShift than what I'm running here today. The name of the APB itself, the description, whether it's bindable or not, which basically means allow it to provide credentials or secrets. And in this case, I don't have anything like that that's necessary. And then we get into the metadata, which is the display name. So that name, when I was in the service catalog, it shows up as VNF asterisk and then in brackets APB, noting that it's an APB. The long description that you can see when you click on it, the image URL for the icon. And then you get into these kind of neat things called plans. So plans, there can be multiple of them. And really the best example of that is inside the catalog here. You'll see some of them. Let's see, Elasticsearch is a good one. So I click on Elasticsearch, click Next, and I have these plans, ephemeral or persistent. And the difference between that is ephemeral means that when the pod gets deleted, all the data that it was created with it is stored in effectively a scratch disk, and that data just goes away. When it's persistent, it's going to leverage persistent storage inside of Kubernetes, and so you have to have already pre-configured that. So in our case, I'm using Gluster as a storage backend. There's Ceph, you can use NFS, there's a bunch of different storage backends that you can leverage. And so what that means is there's a persistent volume claim that gets requested, and that claim says, hey, I'm requesting 2 gigs of storage. So let's say, and we can do that from here, we click Next, and the cluster size, the memory limit, and Elasticsearch storage. So let's say I did 2 gigs, I want to request it, right? So what's going to happen is I'm going to make that PVC. I'm not going to, this actually APB is going to do all of this work for me. It's going to ask Kubernetes, okay, I need 2 gigs of storage somewhere, and then if it can provide it, it's going to create a persistent volume for you, which is a block of data that has been set aside for you, and you can bind to it, and you can write your data into it. And then if you ever had to delete Elasticsearch, but you didn't want the data to go away, so this would be, say, in lifecycle management. Say I'm upgrading my database, so I'm throwing away my pod and spinning up a new pod, and when that MySQL comes up as, say, from version 5.2 to 5.21, it basically reconnects to the existing persistent volume, and all your database information is still there effectively. So That's the idea behind plans. The idea, why would you use ephemeral? I'm testing, I don't care about the data. I just need to validate that something's working, or it's throwaway data, and I just expect it to go away. So like a temp disk, effectively. So in this case, I just have a default one. That's why you didn't see anything. When I clicked on it, it was just, click next, click next, click next. And it's just going to do everything for you. So that's the apb.yaml. The big one is the Docker file. So from Ansible Playbook Bundles / apb-base, this is the container image that's going to contain the Ansible runtime so that we can actually do all of this. And so what it's going to do is when it's building, it's going to copy in everything out of the Playbooks directory and put it into this, this directory that the Ansible Playbook Bundle / apb-base is expecting to happen. It's going to copy everything else out of this local directory into a role called vnf*apb. Again, this is all internal to the APB itself, and set some chmod parameters, run as the APB user. And then the big thing here is this label, com red hat apb.spec. This looks scary, but it's entirely generated for you. Does anyone want to guess what this is?
I don't even know.
So all it is the contents of this in base 64.
Great.
So yeah, so whatever's in here, when I run apb bundle prepare, it's going to write out rote b64 encoded apb.yaml to Docker file. So that's all it's going to do. So this Docker file, and the nice thing is I can change the order of this, I can move all the stuff around, and it's really any of this stuff that happens up here. So let's say I had some preamble stuff that I needed to do. So I wanted to run, and I wanted to, I needed to yum, say yum install Ansible. I don't know, something like, or not even Ansible, sorry, like Asterisk, right? I could add that in there. My Asterisk could be installed for me during when this gets created. And then when I get out of this and I run apb bundle prepare, which in this case I don't actually have to do because nothing is going to change. But it only looks for this label name. So you'll notice that it hasn't changed. It hasn't deleted that line that I added. It hasn't done anything. The only thing that's going to change is in this label line. It's going to look for that specifically. So if I change the apb.yaml, let's say I change the plan from default to awesome, apb bundle prepare, and then it's going to be hard to see the differences, but
yeah, git diff it.
Oh yeah, you're right. I could do that. If I can get out of. Okay, so we can see that it changed a little bit basically, but again, it's base 64, so most of it's all the same.
Right. So it removed that line and did a new one. Okay, gotcha.
I don't really need to change this back. It doesn't matter. Okay, so apb bundle prepare. Step 1. So now what it's going to do is it's giving me these two commands. So within OpenShift, there's basically pipeline and build management stuff. So I've already run this command. So I've created a new build, and I've done a start build, which I'll show you again in a second. But if I go over to my OpenShift project, which is hosting all of this stuff, I have builds. And so I have my vnf *apb build that exists in here that I created with basically my new build command. And so that set it up. It kind of sets a structure inside of OpenShift. And so when I go and run this command, if I can find where I am. So let's see, OC start build, follow from directory here in the OpenShift namespace, because that's where the actual build in the container image is going to end up living. And the bundle name that I called it, vnf *apb. So it's going to upload the local directory up to OpenShift, which is then going to start a new build. And effectively what it's doing is it's building a new container image out of that Docker file.
And like that container image that it built, that's the sandbox that is started at the beginning,
It's the sandbox, and it's all the things that came after that, because it's from that sandbox.
Okay.
So if I added...
does that include vnf * itself? Or
It includes the Ansible for VNF
Okay.
Asterisk. So,
Okay,
so
gotcha.
this entire directory that we see here, as part of this Docker file, we said copy playbooks into, so deprovision and provision, which are the playbooks that allow us to spin up and tear down the APB itself. That gets copied into opt APB project within this container image. And then we're also copying just everything else, which is the entire everything in this directory. It's a little sloppy, but it works. So it's copying, for example, the defaults and the tasks. So the big one is the tasks. So what is it actually doing when we're running? So it's going through, it's updating last operation. All this is doing is saying, hey GUI, update the GUI when the APB is running to say, I've started effectively. I set some facts, which are just variables inside of Ansible. And so cluster, in this case, is doing a lookup to determine, am I running on vanilla Kubernetes or am I running on top of OpenShift? Perfect. And then, so I'm just running through a loop. And this loop is using the Kubernetes module. And it's taking the Jinja templates that exist in this list, and it's running them all. And so all of these, so I'm running a bunch of config maps, I'm spinning up some pods, I'm creating some services, and then eventually I'm creating a deployment that just puts this all together. And then I say that update last operation, and I'm done. So that's all it's really doing. And so that's it. That's the whole APB. We can look at maybe one of the templates. Just for fun and profit. So let's look at the VNF UI just because I talked to it a little bit. Just a Jinja template has some information in here. This is all just Kubernetes stuff. This is a spec, what container am I running, what I'm mounting, what volumes, things like that. So this can all be configured and set up any way that you want for that to be added to the container image so that when you spin up the APB, all this gets run against Kubernetes and instantiates all your objects for you. One last thing I'll show. Oh, I probably won't show that. Oh yeah, so all of these images are being pushed. So when I build it, OpenShift is providing you a Docker registry. So when the build happens, that container image is created, it's pushed into the local Docker registry, so it's not actually pulling anything remotely other than the VNF asterisk components. The actual APB itself, which is a container image, is stored locally within an image stream inside of OpenShift. So if I go back to my builds, I can see a history of all the builds. So if I ran this 2 more times, I'll start actually getting like a pretty graph showing me the history of, actually. Any questions? That's pretty much it at this point, and we are nearing lunch. Does anyone want to see anything else?
All right, well, thank you. Oh, Matt, go ahead.
Within an Ansible Playbook Bundle, do you have the ability, I mean, obviously you get the nice syntax of Ansible YAML. Do you have the ability to use other Ansible modules within that Playbook Bundle as well? Okay, right.
Yeah, the Kubernetes, the entire Ansible, yeah, so the Kubernetes module is shipped with Ansible.
Gotcha. Very cool.
And Ansible doesn't copy it.
Yeah, it does. So we're leveraging. So when I have my APB.YAML, if I had asked information, say I wanted to name it something different, right? Like, what do you want to call this instance of Asterisk? I could call it blue or green, for example. So I could ask for that from the APB.YAML, and when I did that, that's stored as a variable that's available to Ansible when it's running. And so when I have my Jinja template that I showed, I could say, instead of calling it VNF-asterisk, I could change it to whatever that variable name was. You know, APB-name, right? Maybe that's what I called it. And then, yeah, you can, and then, so all of that stuff you can leverage. So if once you get into 4 of these, then you start getting a nice pretty log showing how long it took to build and you know, whether it failed or not during the deployment, or sorry, during the build process and all that.
And you're certainly getting the really quick builds after the first.
Yeah, you can see how much faster it
because
is.
of the cache. So, you know, it only had to rebuild a layer or
It's a
two.
little bit more automated than last year.
Yeah, it's significantly more
Yeah,
automated
that's
than it
for
was
sure.
last year.
Yeah.
Significantly more automated.
Last year was a little bit faster.
Yeah, it was rough because we
Yeah.
had just figured it out. But yeah, now it's browse catalog and, oh, I'm in the wrong project, but
Shift.
yeah, go here, go to the end, click, click, and then just wait and you're done.
Yeah, it's a little bit better than having to run 20 commands. In part, we wanted to show you some of the guts so you could get your hands on it, but this year we're like, okay, enough of the theory, let's see it in practice, and you know,
Let's
your life
do
is
something.
your life is way better.
So if I wanted to customize the DNF asterisk to change the version, or I don't know, maybe put in a particular module that I might have in my back pocket, like how would you go into the actual, digging into the actual guts of there to go tweak out the Docker file?
So what you could do is if you had, so you have your Docker file here, right? And so really what you're doing is leveraging, let's see, pod, oh wait, it's under the deployment, right? So this is actually spinning up our asterisk. And so again, app name and all that stuff is in here. But what I'm pulling is this app image. And so under the apb.yaml, let's say I had a specific list of versions. I had an enum. So I can build an enum that says I want version 14, 15, or like 15.1, 15.2, 15.3, or whatever. Do that as a drop down. And so when I do my app image, as part of that, I can say, okay, they selected 15.2, which means pull down from dockerhub.com/asterisk colon, and then that version. And then when it's deploying this deployment, it will use that image that you set it to use. And there can be a default image that you would set.
And
Use a
if
custom image registry if I had my own.
Yeah, yeah,
totally.
yeah.
And so something also you could do is in OpenShift or with other tooling is you can make like a build pipeline. So you could say like, hey, I want to make my like super cool asterisk build, and I want to build it this way that compiles this custom module or whatever it is, and I want to compile it with 2 versions back or something like that. And then you could reference them here, or
You could have a text box that just said whatever version you want, and then if you're pulling it out of, say, the local build pipeline or whatever, then you just type in the version, spin it up, and it'll grab the image out of the local registry. So if you had a build pipeline that was, say, every time I make a change to asterisk, it follows, say, GitHub, webhook, basically triggers a Jenkins build, runs through the test. If it passes and it actually builds successfully, then it pushes it into the local registry, and then I could go to my APB, click on it, and say I want version, .awesome or .new or latest, for example, and then just run that, and then when you spin it up, it'll grab that latest image out of whatever registry you tell it to. So, yeah, so you can tell it whatever you want because it's just Ansible and it's all super extensible. So, all right, lunch is walking distance, so we'll call it.